No human being has ever fallen into Jupiter, but if you did, you would not hit the ground, because there is no ground. What you would find instead is something far more terrifying. And the deeper you fall, the more impossible it gets. Jupiter is the largest planet in our solar system. It is so massive that 1,300 Earths could fit inside it. But nobody truly understands what lies beneath those clouds. Until now. If this is the kind of question that keeps you up at night, hit subscribe, because we're just getting started. 4.5 billion years ago, our solar system was nothing more than a spinning cloud of gas and dust. Gravity pulled matter together, slowly at first, then faster, then violently. The sun ignited at the center, and what remained swirling in the outer regions began to clump. Most of it, the hydrogen, the helium, the raw material of the early universe, gathered in one place. That place became Jupiter. Jupiter did not form the way Earth did. Earth is a rocky world, built from silicates and iron and carbon, compressed over billions of years into a solid sphere. Jupiter took a different path. It grew so fast and so large that it captured enormous amounts of hydrogen and helium directly from the solar nebula, the cloud of material surrounding the young sun. In less than 10 million years, a blink in cosmic time, Jupiter had already become the dominant force in our solar system. It had swept up more material than all the other planets combined. Its gravity was so powerful that it shaped the orbits of everything else, including Earth. Without Jupiter acting as a gravitational shield, our planet would have been bombarded far more frequently by asteroids and comets. Some scientists believe that life on Earth might not exist at all if Jupiter had not been there to absorb or deflect countless deadly impacts over billions of years. Today, Jupiter sits roughly 480 million miles from the Sun. It takes nearly 12 Earth years to complete a single orbit. Its diameter measures approximately 86,800 miles, more than 11 times the diameter of Earth. And yet, despite its colossal size, Jupiter spins faster than any other planet in our solar system. A single day on Jupiter lasts only about 9 hours and 55 minutes. This rapid rotation is responsible for the powerful atmospheric jet streams that carve the planet's surface into those iconic bands of orange, brown, cream, and white that we see in photographs. But what is Jupiter actually made of? The short answer is mostly nothing solid. Jupiter is classified as a gas giant, though some scientists now prefer the term fluid planet. Its atmosphere is composed of approximately 75% hydrogen and 24% helium, with trace amounts of methane, water vapor, ammonia, and other compounds. As you descend deeper into the planet, the gas does not suddenly end. It simply becomes thicker, denser, hotter. The pressure builds so gradually and so relentlessly that there is no clear line where the atmosphere ends and the interior begins. It is a continuous transition from gas to liquid to something that does not exist on Earth at all. This is the first thing you need to understand before imagining what it would mean to fall into Jupiter. There is no moment of impact, no surface to crash against. You would simply begin to slow down, and then the planet would begin to consume you. The temperature of space in the region around Jupiter is approximately minus 220 degrees Celsius. The moment you enter the upper cloud layers, however, things would change rapidly. The topmost clouds of Jupiter sit at roughly minus 145 degrees Celsius, cold enough to kill a human being almost instantly without protection. But cold is only the beginning of what Jupiter would throw at you. Jupiter's atmosphere is not calm. It is arguably the most violent weather system in the solar system. The Great Red Spot, the enormous storm that has been raging on Jupiter for at least 350 years, is wider than the entire Earth. Wind speeds inside this storm reach up to 380 miles per hour, but that is not even the most powerful wind on Jupiter. Near the equatorial jet streams, wind speeds can exceed 330 miles per hour, sustained, constant, never stopping. There is no eye of the storm on Jupiter. There is no calm center. The entire atmosphere is in perpetual planetary scale chaos. If a human being, even inside the most advanced spacecraft ever conceived, began to descend through Jupiter's atmosphere. The first obstacle would be the wind. Within seconds, the spacecraft will be caught in jet streams, moving at speeds that would tear apart any structure we are currently capable of building. The engineering required just to survive the upper atmosphere of Jupiter is beyond anything that exists today. But let us assume, for the sake of this thought experiment, that the vehicle is indestructible. Let's follow the fall all the way down. At approximately 30 miles below the cloud tops, the temperature has already risen to 0 degrees Celsius. The pressure is roughly 10 times what we experience on the surface of Earth. This is already beyond what an unprotected human body could survive. The bends, the dangerous condition, diverse experience from pressure changes would be irrelevant here. At this depth, the pressure alone would crush a human body the way a hydraulic press crushes an aluminum can. The process would be over in milliseconds. But the indestructible spacecraft keeps falling. At around 600 miles below the cloud tops, something extraordinary happens. The hydrogen in the atmosphere, which has been getting denser and denser, begins to behave not as a gas, but as a liquid. There is no splash, no surface to break through. The transition is seamless. One moment you are falling through thick gas. The next, you are sinking through an ocean of liquid hydrogen. An ocean with no bottom, no shore, no coastline, and no light from the sun. The temperature here exceeds 3,000 degrees Celsius. The pressure is 100,000 times that of Earth's surface. Nothing built by human hands has ever come close to surviving these conditions. The probe that the National Aeronautics and Space Administration sent into Jupiter's atmosphere in 1995, called the Galileo probe, was destroyed at a depth of about 120 miles after just 57 minutes. It was one of the toughest spacecraft ever built. It was obliterated. Keep falling. At a depth of somewhere between 13,000 and 19,000 miles, the pressure becomes so extreme, estimated at around 3 million times Earth's atmosphere pressure, that the liquid hydrogen undergoes another transformation. It becomes what physicists call metallic hydrogen. This is a state of matter that does not naturally exist anywhere on Earth. In metallic hydrogen, the electrons are stripped away from their atoms and flow freely, just like in a metal. This is what gives Jupiter its extraordinarily powerful magnetic field, the strongest of any planet in the solar system, roughly 20,000 times more powerful than Earth's magnetic field. The metallic hydrogen is the engine of that field. It is conducting electricity on a planetary scale, generating a magnetosphere so vast that if it were visible to the naked eye, it would appear larger than the full moon in our night sky. A human being inside a spacecraft at this depth would be experiencing pressure equivalent to standing at the bottom of an ocean 40 miles deep, multiplied by millions. The concept of survival is no longer relevant. The concept of the spacecraft itself is barely relevant. At these pressures, the atomic structure of most metals begins to fail. The very molecules that form the walls of any container we know how to build will be forced into configurations that compromise their integrity. And yet, we still have not reached the core. Scientists believe, though no probe has ever come close to confirming this, that Jupiter has a core. It is not a core like Earth's iron core. It is a dense, rocky, possibly partially molten region somewhere between 10 and 45 times the mass of Earth. It sits at depths of perhaps 30 to 40,000 miles below the cloud tops. The temperature at the core is estimated to reach 36,000 degrees Celsius, hotter than the surface of the sun. The pressure there is believed to be around 45 million times Earth's atmosphere pressure. Nothing from our world could exist there. Not metal, not ceramic, not any composite material we have ever engineered. At those conditions, matter itself behaves in ways we are still struggling to understand theoretically. Now here is the question that the scientific community has been wrestling with for decades. Is there life on Jupiter? The honest answer is, we do not know. And that uncertainty is itself remarkable. Carl Sagan, one of the greatest scientific minds of the 20th century, speculated in the 1970s that certain regions of Jupiter's atmosphere, at moderate temperatures and pressures, might be habitable for simple life forms. He imagined creatures he called sinkers, floaters, and hunters, theoretical organisms that could exist within Jupiter's cloud layers, surviving on chemical reactions rather than sunlight. This was not science fiction. It was serious scientific speculation based on the chemistry of Jupiter's atmosphere, which contains carbon, hydrogen, nitrogen, oxygen, and phosphorus, the building blocks of life as we know it. More recently, researchers have pointed to the presence of water in Jupiter's atmosphere as a potentially significant factor. The Juno spacecraft, which the National Aeronautics and Space Administration launched in 2011 and which has been orbiting Jupiter since 2016, has detected water in Jupiter's equatorial region at concentrations significantly higher than previous estimates. Water is not proof of life, but it is a necessary ingredient. No scientist today would claim that life definitely exists inside Jupiter. The conditions are simply too extreme in most regions. The lightning storms alone, which produce bolts estimated to be 3 times more powerful than Earth's most powerful lightning strikes, happening continuously across the planet, would represent an enormous obstacle. But the possibility has not been ruled out either. And in science, possibility matters. What the experts do say, with certainty, is that Jupiter holds the key to understanding planetary formation throughout the universe. Because gas giants like Jupiter are the most common type of large planet detected around other stars, studying Jupiter tells us something fundamental about how solar systems are built. The data returned by the Juno mission has already rewritten several assumptions about how Jupiter's interior is structured, how its magnetic field is generated, and how its atmosphere circulates. Every orbit Juno completes adds to a picture that is more complex, more surprising, and more alive than anyone anticipated. Which brings us to the question that changes everything. The question of what it would actually cost to send a human being, or even just a serious crewed mission, toward Jupiter. Let's be direct. No space agency in the world currently has plans to send human beings to Jupiter. The planet is simply too far, too hostile, and too poorly understood for crewed exploration to be a realistic near-term goal. But the financial picture of what it would take is itself staggering enough to be worth examining in detail. The Galileo probe mission, an uncrewed robotic spacecraft, cost approximately $1.4 billion United States dollars in total. That mission took 6 years to reach Jupiter after its launch in 1989. The Juno mission, launched in 2011, cost approximately $1.1 billion United States dollars for the spacecraft alone, not counting launch costs or operational expenses. These are the price tags for robots. Small, unmanned, one-way instruments with no life support, no return capability, and no crew. For a crewed mission to Jupiter's orbit, not descend into the atmosphere, just orbit, the estimates from aerospace economists and mission planners range from $100 billion to over $500 billion United States dollars, depending on the timeline, the propulsion technology available, and whether the mission would be operated by a government agency or a private company. For context, the entire Apollo program, which landed human beings on the moon between 1969 and 1972, cost approximately $280 billion United States dollars in today's money. A crewed Jupiter mission would dwarf Apollo in every dimension. The journey alone would take between 2 and 3 years using conventional chemical propulsion. The crew would be exposed to deep space radiation at levels far beyond what the International Space Station crews experience. Jupiter's radiation belts, driven by that immense magnetic field, are so intense that they would destroy unshielded electronics within hours and deliver lethal radiation doses to a human being in less than a day. The spacecraft would require massive radiation shielding, adding enormous weight, which means more fuel, which means more cost. Some engineers and futurists have proposed nuclear thermal propulsion as a way to cut the journey time significantly, potentially to under a year. But nuclear propulsion systems for crewed spaceflight remain in the research and testing phase. They're not ready, and developing them to operational status would itself require tens of billions of dollars in investment before a single mission could be planned. SpaceX, the private aerospace company founded by Elon Musk, has occasionally floated ambitions beyond Mars. But publicly stated goals for private spaceflight companies currently extend only to Mars at the furthest. Jupiter is a different order of magnitude, not just in distance, but in every technical challenge involved. The most realistic pathway to a deeper understanding of Jupiter in the coming decades involves increasingly sophisticated robotic missions. The European Space Agency's Jupiter Icy Moons Explore mission, launched in April 2023, is currently en route to Jupiter and is expected to arrive in 2031. It will study Jupiter's moons, particularly Europa, Ganymede, and Callisto, which are believed to harbor liquid water oceans beneath their icy surfaces. Europa alone has become one of the most exciting targets in the search for extraterrestrial life in our solar system. The cost of that mission is estimated at approximately 1.6 billion euros. What would it cost to actually descend into Jupiter's atmosphere with a crewed vehicle? Not just orbit, but descend. Honestly, the question is almost impossible to answer with real numbers because we do not yet have the technology to even begin designing such a vehicle. The materials science alone, developing substances that could withstand pressures of millions of atmospheres while maintaining structural integrity, would require decades of basic research. The propulsion needed to slow a crewed vehicle through Jupiter's atmosphere and then somehow return it to orbit would demand energy outputs that are currently theoretical. Some scientists have compared it to asking what it would cost to build a time machine. We can describe what it would need to do. We cannot yet describe how to build it. What we can say is this: Jupiter is the frontier beyond the frontier. It is the place where our physics gets tested, where our engineering reaches its absolute limits, where our understanding of what a planet can be gets rewritten with every data point we collect. And the more we learn, the more we realize how much we do not yet know. Jupiter has been watching over our solar system for 4.5 billion years. It shaped the orbits of every world we have ever known. It absorbed impacts that might have ended life on Earth before it had the chance to begin. It holds more secrets in its churning clouds than we have managed to uncover in the entire history of human science. And when we finally build something capable of truly exploring it, not just passing by, not just skimming the surface of its moons, but going deep, what we find there will almost certainly change everything we think we know about our place in this universe. The fall into Jupiter would not be a fall into darkness. It would be a fall into understanding. If you made it to the end of this video, you are exactly the kind of person this channel was built for. The universe is full of questions that nobody is asking loudly enough. Every week, we take one of those questions and we go as deep as it takes to find a real answer. Not a surface-level summary, not a list of fun facts. A genuine, honest, scientific dive into the most extraordinary places and ideas in existence. Subscribe right now and turn on notifications because the next video is already going to change the way you see the sky above you.